Hey everyone, welcome back to the channel. Today we're diving into one of the most fundamental parts of Python, numbers and math operations. Whether you're just starting out or need a quick refresher, by the end of this video, you'll understand how to work with numbers, perform calculations, and even use Python's built-in math module. Let's get started. First, let's talk about the types of numbers in Python. There are three main types we'll use: integers, or int for short, which are whole numbers like 5, 100, or -3. Floating point numbers, or float for short, which are decimal numbers like 3.14 or -0.5. And complex numbers. Complex numbers are numbers that have two parts, a real part and an imaginary part. For example, 2 plus 3j has a real part, which is 2, and an imaginary part, which is 3. In math, the imaginary unit is usually written as I, but in Python we use j instead. The j tells Python that the number is imaginary, kind of like how the unit m in 5m tells you it's meters. So when you put a real number and an imaginary number together, you get a complex number. Python automatically recognizes these types, so you don't need to declare them explicitly. Here's some example code. Let x equal 10, y equal 3.14, and z equal 2 plus 3j. X is an integer, y is a float, and z is a complex number. We can use print statements with the type function inside to show the type of the variables we just made. We'll do print type x, print type y, and print type z. If we run the code, you can see Python tells us the type of each number using the type function. X is an integer. That's the first variable we printed out. Then we print out the type of y. Y is a float. And then we printed out the type of z. And we can see that z is a complex number. Next up, let's do some basic math. Python supports all the usual operations: addition, subtraction, multiplication, division, floor division, which is written as 2 forward slashes and divides two numbers and gives you only the whole part, ignoring the decimal. Also, it supports modulus, which gets the remainder from division, and also exponentiation, which is the power. Here's some example code with these operations. Let's say a equals 10 and b equals 3. Then we'll print these different math operations. We'll do print a plus b, print a minus b, print a times b, print a divided by b, print a floor division b, print a modulus b, and print A to the power of B. Okay, let's run the code. So A plus B gives us 13. A minus B gives us 7. A times B gives us 30. A divided by B gives us 3.3 repeating, but it ends with a 5. Now, 10 divided by 3 is actually 3.3 repeating forever. And when you divide 10 by 3 in Python, you'd expect 3.3 repeating forever. But computers can't store repeating decimals exactly, so they approximate them with a binary representation. That's why you see the 3.3 repeating that ends with a 5 instead of a perfect repeating 3.3. It's normal in all programming languages. Okay, on to floor division. A floor division B gives us 3. A modulus B gives us 1. A to the power of B gives us 1000. Notice that floor division, which is 2 forward slashes, gives only the integer part. Also, modulus, the percent sign, is really handy for checking remainders. Something else to note here is that in Python 3, the division operator always gives a decimal, a float, even if the answer is a whole number. For example, 4 divided by 2 gives 2.0. So I'll print that out so you can see it in the terminal. Here it is. Okay, Python follows the standard order of operations, like in math class: parentheses first, then exponentiation, then multiplication and division, and finally addition and subtraction. Here's some example code. Let's say result equals 2 plus 3 times 4, and then we print results. That'll give us 14. Then we can make results equal parentheses 2 plus 3. And then after that parentheses 2 plus 3, make it times 4. Okay, so the first time we got 14, and we can see here the second time we get 20. Using parentheses can change the order of operations to get the result you want. Python also has some built-in math functions for common tasks like rounding or absolute values. Here's some example code. Let num equal negative 7.5. We're going to print the absolute value, then we'll round the number, and then we'll round it to 1 decimal place. So print abs parentheses num, print round parentheses num, and print parentheses round parentheses num comma 1. Okay, let's run the code. For the absolute value, we get 7.5. For the regular rounding, we get -8. And for rounding to one decimal place, we get -7.5. For rounding to one decimal place, the reason it stays the same is because the number already has exactly one decimal place, so there's nothing to change. Alright, and ABS parentheses gives the absolute value, and round parentheses rounds the number. To round to a specific number of decimal places, you add a comma after the variable, and then the number of decimal places you want to round to, like we did here. For more advanced math operations, Python provides the math module. To use it, you first type import math at the top of the file. Okay, so we did import math, and now we'll do print math dot square root 16, print math dot ceiling 3.14, print math dot floor 3.14, print math dot factorial 5, and also print math dot pi. So math dot square root 16 gives us 4.0. Math dot ceiling gives us, or math dot ceil gives us 3. Math dot ceil 3.14 gives us 4. Math dot floor 3.14 gives us 3. Math dot factorial 5 gives us 120, and math dot pi gives us those digits of pi right there. So here's what these functions do. Math.square root gives you the square root. Math.ceil rounds up. Math.floor rounds down. Math.factorial gives you the factorial of a number, and math.pi gives the value of pi. There are many more functions in the math module, like sine, cosine, logarithm, and more. Here are some quick tips. Use 2 forward slashes, which is floor division when you only want the integer part of division. Use the percent sign modulus to check remainders. The math module is your friend for more complex calculations. And always remember the order of operations, which is also called operator precedence, to avoid bugs. So today you learned how to work with numbers, perform basic math operations, and use Python's math module. These basics are essential for everything from simple scripts to advanced projects. If you found this video helpful, make sure to hit the like button, subscribe, and turn on notifications so you don't miss any videos. Thanks for watching.